Aloha, Richard Halverson here. This is ITS148, and today's September 16th. Let me share my screen. And right now we are, if you look at the syllabus, we are like around here. And so I'm going to talk about classes today, and I'm going to go over one of the labs here. So let's just hop right into it. Here is, let me go to, it looks like nobody in classes, it looks like nobody started the last lab. So maybe I'll go over that today. It turns out that because of my style of teaching, where I like everybody to do as well as they can, regardless of how much help they need, it turns out that I have difficulty measuring whether I improve as an instructor from semester to semester. Because normally, or for the most part, most everybody who finishes the course ends up with pretty high scores. So it's hard to tell from semester to semester. So what I'm going to do is I'm going to have you do some assignments, some labs, probably, where I'm going to give you very little help, but they will be scored the same as all the rest of the assignments. So, so if there's like I don't know how many labs there are, but if there's 50 labs, and labs are 20% or whatever, one lab is less than 1%, and so there will be like maybe 5 labs where I'll be able to look at just those labs, and those will sort of distinguish between folks that find coding, the computational thinking that goes on to code, if they find it easy or not so easy. And so that way I can get a range. And right now there's not a really good way for me to get a range, because I like everybody to get all the points. Okay, but there'll be like 5 of them where I'll score them, and they won't be, that should be, so it's kind of like a midterm or a final. But trouble with the midterm and a final is that it weighs so much, and it's counterproductive for really what I want to do. I just want to be able to gauge my improvement as an instructor from semester to semester. So I'll just so I'm going to tell you that, and I haven't chosen the assignments yet, but there'll probably be something out of here, and you'll just notice, or I'll tell you, well, I want you guys to do this on your own, and I want to see how you do. And the fact of the matter is the weight on your grade will be very, very small, because you add up all these assignments together. But that particular assignment I'll be able to use to help gauge my compare this semester with next. So it'll be in the aggregate. It won't be used specifically in the aggregate from semester to semester. So anyway, but this product class one that I'm going to go over today looks like a good one, but I'm not going to use this one because I'm going to show you how, because it's a good lab to talk about what the important things about classes are. So today I'm going to go over the introduction to classes. I'm going to breeze through just the first screen of these. I'll talk a little bit about class constructors. It turns out that the only thing that is new in this chapter is these labs. So you haven't seen these labs before from 128, but you have seen all of these. The reason that we go over it twice is because the concept of classes, and so this is a standard thing in every programming language that would after about 1990, written after about 1990. Well, in fact, all programming languages have classes now, but back before 1990, programming languages didn't have classes. And what we used to do back then was we used to write our code and we used to group variables together, just like, like physically in our programs, we used to group special subroutines together, and we would only use those subroutines on those variables in this group. So we would be thinking and designing like classes, but the language didn't in any way enforce it. Now the language enforces it. So anyway, so if we look at classes, classes are just a way of grouping items into objects. And so, you think of you might think of the world is viewed as material, not as materials, but as objects. So you don't see the attributes of the chair or the couch or the drawer in this picture. You see a chair, a couch, and a drawer, and then those chairs and so on, they have different attribute values, but so that's the idea. And so once you define sort of a representation of a chair or what pertinent information you're going to store about a chair, then you can say, well, this is a class, and these are going to be chairs, and I can create multiple instances of chairs. I can have 5 chairs. They're all different in some way, but yet they're all chairs. And so program not viewed as variables as functions, but rather as objects. And so here you have examples of these would be classes, and there are some things that you have a restaurant class, and there are not only values or attributes that go along with like number of rooms and variables, but there's also these functions, and that's these subroutines or these methods, as we call them today. We call them the methods. And so these are methods because they're having you're setting some attributes, you're writing into them, and here you're adding something to some sort of table, presumably. Here you're adding something, and here this is a method, but then these would be just data values. Okay, and these are all characteristic of what you're interested in about a restaurant. Restaurants can have attributes that you are not interested in, like whether they're a storefront, or whether they're in a food court, or whether they are inside a building on the 5th floor, or so on. For the purposes of what we're going to be using this class for, this is all we care about. So you have variables and you have methods, and basically and you can create instances of them. And when you're creating an instance, you define a class, and then you're going to create, so you define a chair and class, and then you're going to designate 5 chairs, because you have 5 chairs in your house and they're all different colors. So you create 5 instances, and those will be 5 objects based on the class chair. And with these methods, you're able to do various things, like the add cuisine method is going to certainly have some parameters along with it, that some characteristics of the cuisine that you're adding, and also creating the instance from scratch, or creating the object to begin with. You can have parameters there also. So anyway, we're going to talk about more of that when we talk about class constructors. But anyway, that's the important thing about classes, so it's you have to make sure information hiding. There's classes can have internal variables. is one example of that. And here we're talking about information hiding encapsulation. So here's, just so you understand, a car represents an abstraction to a user, including a steering wheel, a gas pedal, and a brake. So when we think about a car, we think about, okay, steering wheel, and steering wheel used to steer it, gas, whatever. Brake. Here's a different example of an abstraction, which would be of a refrigerator, and when we think of a refrigerator, there's, a refrigerator is free on gas, a compressor, a fan. That's not an abstraction for the user. That may be an abstraction for the manufacturer, okay, or the parts supplier or something, certainly, but not for the user. So I believe that's right. See, I haven't answered it yet. I don't have a check mark over there, so I'm going to say false, and yes, okay. All right, so so Python automatically creates built-in objects. A programmer interacts with these built-in objects. Like here, for example, when you say this variable name is equal to a value, this is a string variable, and it's equal to this value. Well, actually, it's like an object. Is this right? Yes. Yes. So then you can use these methods tacked onto this, and you are actually performing this method on the contents of this, which is this. And so that's why, when you're assigning a value to a variable, you're actually creating an object. And along with that comes whatever methods go along with the object, type, variable type, string in this example. Python language provides a built-in object for strings. Yeah, I guess. I'm going to say yes. Watch, it's going to, okay, great. Okay, so you should go through that because you get points for that. Okay, here are the optional ones because you've done all these already, and I'm not. The reason they're optional is because I'm not even going to make you look at them because if you wrote a bunch of code already, like we have in 128. You should kind of know all this already, but you may want to use this as reference. When you're writing your code, you may want to think about, see, where was the reference on that again? And you remember it was chapter 9 of this book and that you had last semester. So that's why I have these. But so here, this talks about grouping data. And so it's sort of what makes sense, hours and minutes. This dot notation is, so here we're creating, there's a class, and the class has two of these attributes, and so this creates the instance. This creates an instance of that class, and we're calling it time1. And so this is how we can set this value in this instance of this class. You just do this, it makes sense. So here we're creating multiple instances of that. So now we have 2 of them, so this demonstrates that. So that's all this is about, grouping data. And that's something a class does. You don't have to do this. You can have all just separate variables, and, somehow you have a naming convention, and, that's, this class, you have some sort of name and an underscore or something. And that's the way we used to do it back in the 70s and the 80s when we write code. We would be these software academics and this new, structured concept of a class. And so we would write our code like this. And anyway, And so here, this talks about the methods that can go along with classes. So here we have a class, and here we have a method that goes along with the class. And so when you create an instance of this, you get this method right along with it, and you can use it. And so here, you created this class called time1, and we have this method now that will print, this value, and it'll print this value, because it's this value, just by executing that statement. And so all this shows is that you can include methods along with your variables. And so that's this section. And so you should go through this. If you haven't seen this before, you should go through it, but you won't get any points for doing it just because they're optional. And the folks that took, the people that took ITS148, of course, last semester got points for this. But it just sort of tests your understanding now. So this is optional. I don't know if my textbook is different than yours, but can I still do it? I think I can still do it. Oh yes, okay. So it's just that I won't get the points. When I download the scores, these optional sections are not even included. So that's what we mean by not getting the points. So here we're creating a class. We have a class called person, and when we create an instance of it, there's this variable in there called first name, and it's set equal to a blank. And so before you do anything with it, you better set it equal to something. And then also, once we create an instance of it, this method comes along with it, and when we execute this method, it prints out what the value of this variable is. And so that's what we're doing here. First, we create an instance, then we set first name, and then we execute this, and we're supposed to say what is this going to be? Well, I think this is going to be Joe. No, it's going to be he is space Joe, and enter. Now, sometimes this enter matters, and sometimes this enter doesn't matter. And I'm going to show you what. So I'm going to do this, and this is an answer that somebody might put in. And so right now I'm going to check it, and it will say wrong because I am missing. It expected that return. Okay, so good. So it still does that. It's consistent. So now that I didn't get number 1 right, I get to do it again. Is it the same one? Oh, it's the same one. It's not normally the same one, I think. Okay, anyway, now it's right. Okay, so that, and this is another challenge activity again. If you want to make sure you understand these concepts, you can do these. So we're supposed to write you want to add this method right here. So you'd put something like, there would be a def, and the method is going to be inc num kids, and you got to put this self thing in here, I guess, colon, enter, and then you're going to say, you're just going to increment it. Yeah, okay, so it'd be self.num kids incremented by 1. I think that's all you do. Let's see, run. Huh. This is actually a challenge. Oh, okay. Anyway, good. All right, so you got to so make sure you understand that. Class and instance object types. Okay, so what this is talking about is So you can actually refer to this dot this, or you can refer to this dot this, and they're two different things. And that's what, because and basically this is what this talks about, I think. So here you have this class. It looks like this, and this doesn't matter. And here you create two instances of a marathon runner. And so what this is going to print out, this is the name of the class. So this, when you print this out, it's going to print this number out. However, this, when you print out run or race distance, this is the value that's in here, but it could change because you could, assign a new value to it or whatever. You can't assign a new value to this because that's defined here in the class. But here you can, and so these may be different, but this will always be the let's see, does it ever show it? Okay, so here, yeah. So here they're different. So anyway, they don't show this part. Yeah. Anyway, so that's this. So that's what they're talking about here. All right. So make sure you understand that. And this is interesting. This seat reservation example. Whenever you have one of these examples, okay, so all this is you're just supposed to, you can just click through this. So you have this program here, this nice program, and there's times when it asks you to enter stuff, these things, it asks you to enter stuff. And the trouble with this particular platform is, well, what's nice about this platform is it even works on my iPad. But what's junk about it is that, like, you can't even make this box bigger, like in a lot of other things, you can make the box bigger. What's really bad about it is that you have to anticipate the order in which the inputs are going to execute, because you have to put all what the submissions are for all the inputs as they execute down here in the box below. So these are all, this is the first command, and then since it's R, it knows it's going to ask for this for the seat number, and so that's what this is. And then since it knows it's going to ask for the first name, and so that's what this is. And so this is not at all, this platform is not at all like how this program executes, in real life. So my point is, whenever you see something like this, you should open up your, you can open up Visual Studio Code if you want to, or just open up, well, let's see, why don't I open up Visual Studio Code? All right, so I'm gonna open up a command thing, CMD, and I'm gonna go over to my desktop, CD, OneDrive, desktop, and on my desktop I got my ITS148 folder, CD ITS148, and I'm gonna start Visual Studio Code. So to do so, I go CODE space period. Lo and behold, this was the last thing I worked on, I guess there. Okay, so anyway, here we are. And I'm gonna create a new file here. How do I do that? I click something. I'm gonna just go new file. And I'm gonna, select the language. Really? Select the language? Python. Okay, here we go. And I'm gonna save it as seat. Wait a second. 9.9 dash seat. No, 9-5-1 seat. How's that? Okay. I'm going to save it as 9-5-1 seat period py. Okay, there we are. So here's my program. And then I'm going to go over here real quick, and I'm going to grab this whole thing, copy, paste. Okay, there we go. And now I'm going to save it. Save. And now down here, I'm going to run it. I'm going to run it by going, I gotta know what I'm doing here. So let me put this over here. I'll put this over here. And I'm going to get rid of this. And what are the inputs here? See, this is ridiculous. Okay, so let me pull up another little. All right, let me pull up just pull up Notepad. And I'm going to take this stuff, copy, and paste. So those are my inputs. And I'll just put those over. I'm going to put this down here, and I can put this over here now, I guess. And so now I'm going to run it. So I'm going to say Python space. And what's nice about this IntelliFuture, whatever, I can go like 9 dash, and then what happens if I hit the tab? Does this work? Oh, it doesn't work. Oh, yeah, it does that. I think that will do it. So I'm going to hit enter, and there we go. And it's running. See, so let me just go like this, and I'm going to make sure that that's where I am. And I'm following these inputs right over here. So I'm going to go R, enter, seat number 1, enter, Hank, enter, Hill, enter, 275.63, enter, R, enter, 2, enter, Bobby, enter, Hill, enter, 245.22, enter, what's P? Whatever P is, P, and oh, look at that. It says, here's where I entered the P. I see there's 5 seats, and it's show. Okay, anyway, that's fine. Okay, and then a Q. That's weird. So is that what it's supposed to look like? Well, Q. Well, see, I don't need the Q right now. What I'm going to do is go back here, and what happens when I run this? I'm going to run it, and oh, same answers. All right. Okay. So anyway, so whenever you're given these exercises, you can do that. And then, you know, it's also, and I never really talked about this too much, but this is ITS148. So I should talk about testing a little bit. When you're testing your code, you know, I'm sorry, I'm guilty of always just like taking the example that's in the textbook, entering that data. Oh, look, it's the right answer, and then moving on to the next problem. Well, of course, that's a really bad way to test. I mean, that's not testing at all. You should test your code. you basically, if you want to do the most thorough test, is you test every branch of your code, and you test it by testing the boundary conditions of that branch. Okay, so that way, so you're testing every path, every path of your code. And so for here, you know, to test this, you should certainly test all of the commands. And did we do that? Yes, we did. We tested all the commands. We should test this branch. Did we ever test this branch? No, we didn't really test this branch. So each time we took the else case. So we never tested the branch where we tried to enter a seat, the same seat twice. So we never tested this is empty thing. And who knows, we could have misspelled this or something and it'd be dumb. Or maybe there's a whole bunch of logic in here and it's wrong. Okay, so and then the other thing we never tested was the invalid command. We should really test PQ. We should yeah, we should test P, Q, R, and something else, and that would test all the conditions of this and the while. So anyway, I just thought I'd mention that when you're actually really are testing code that you wrote. All right, so enough of that. Let's keep moving here. So class constructors is just where, when you're creating the new instance of something, you can have parameters. And I don't know why I made this. I guess this is pretty important. That's why I made it not optional. So you can go through and click through this again, click these participation activities. And so make sure you do, so you get the points. Here, for example, we're creating, this is going to keep track of race times for somebody. So you enter in a bunch of these parameters for a race, the starting time and the ending time in minutes. And what it'll do is it will compute the time it took to complete the race and output that, and it'll tell you the average pace, your average pace. In other words, minutes per mile. Okay, interesting. Instead of miles per minute. So anyway, and so you can actually take in all the data beforehand and just have it as arguments to the class when you're creating the object, and you just throw arguments in here, and here's what the constructor looks like. Here come the parameters, and this actually takes them and sets them in there like that. So then once this is done executing, you actually already have this thing computed, and here is, or you have it all stored. And then this one, of course, calls the print time, which is this, and it executes this code and prints out the time to complete the race in hours and minutes, and it prints out the pace, which is the next one. Now, to test this code, again, if you test all the branches, you want to test this branch and this branch. So it would be, you test the branch where the ending minutes is not greater than the starting minutes. Yes, it is, because we're dealing with time. Did this do that? So anyway, for how you figure out the time. And then for pace, there's two branches too, so you should test both those branches. All right, so this tests your understanding of these constructors. And so, so if you did not have the constructor, then you can still have it, except for then you have to have statements. You have to be able to set. You have to have setters, at least, or you have to set them. I guess you can. Yeah. No, you don't. You can just do setting them, back this way, like this. You can set them this way. So what having a parameterized constructor is, you may have hours and minutes, comma hours, comma minutes, and then when you created the instance here, you put time 5, comma 30, and time 2 equals time 7, comma 45, and that's all you'd have to do, and then you wouldn't need to have these lines and these lines. So that's what constructors do. Okay, great. Interfaces. It consists of the methods that a programmer calls to create or access a template. I'm not, I've never used interfaces before, I don't think. A class interface consists of the methods that a programmer should use to modify or access. Okay, right. So what they're saying is that you should use wait, I'm not sure. Okay, class user contains interactive. Yeah, okay, so that's instance of this. A programmer calls to print some output. The class interface consists of the methods the programmer calls to create, modify, or access a class instance. Figure below shows the class interface of the race times class, which consists of the init constructor and print time. Okay, so but this is just to create it. There's no modifying in here, and there's not really any accessing either, other than these prints. So let's well, okay, so anyway, all right, it's just talking about a set of methods within a class. Class customization. This is kind of a way of changing to customize a class. A programmer implements instance methods with special method names that the Python interpreter recognizes. So, like for example, this with to change a class instance object, to change how a class instance object is printed, you would define this method inside the class. So normally when you print, so I guess normally when you print truck, okay, truck is it's an object. It's an object of this class, and this class has 3 variables or 3 attributes inside of it. And with this constructor, you can set them all 3 in when you're creating it. And what this does is this prints out the location of where the data is for the class. And so this is a memory location. This is a hex B74CB98C, someplace out there in RAM, I guess. But you can change what this does. And the way you change it is you define a method called that, and then you just say what it does. So now when you print the instance, or print the object, it actually has something, prints out something meaningful that you defined here. So anyway, that's class customization. Is there anything else we customized? Overloading is where you can, like LT has meaning, right? And you can add new meanings to the like less than, where you're saying is one object less than another object. Well, I mean, how do you define less than? Well, here you can. So normally when you would check, this is an object and this is an object, and they're kind of complex. How do you, you have to define somewhere what this means. And of course, with times, it's complex because you've got an hours field and a minutes field, and you have to write some code kind of to be able to, decide whether one is greater than the other or one is less than the other. So that's what this is. That's overloading. See, normally you would do this, and if you didn't have this, and you tried to do this, I don't know, you'd probably get an error. Undefined. It's this operator is undefined for these objects, or objects of this type. And this would fix that. All right, so here's on more operator overloading. It's 114. So let's take a look at this assignment here. So what we're supposed to do is we're going to define a class called product, and by product code, the product has a price. It's got an inventory number for how many of them we have. Yeah, so there's going to be one instance for each type of product that we have. And then you can get stuff out, by these methods. So you aren't just looking directly at internal attributes. You're using these. You're getting them by way of these functions, these methods, which is a better way to do it. So that way the actual value there, the variable that this is stored in, is hidden. The user shouldn't know. So it can have some other kind of name. So that way you control access to the internal variables of an instance of a class by providing these methods here to set them and get them. So if a new product object is created with the code Apple, with code set to Apple, and the price set to this, and the count is set to this, then it's going to output this. Okay, so this is the program down here. I'm gonna go over and use my Visual Studio Code. And what am I gonna do? I'm gonna close this, close this. This is my last time, and I'm gonna make a new one. And I'm gonna do this, Python, Pi. And I'm gonna go over here and I'm gonna call it lab 9-13-1 product class. Okay. Save as 9-13-1 whatever, product. Put a dash there. Product dot P Y. Wait a minute, what am I saving? Is this right? Okay, I guess I am, yeah. All right, here we go. And I'm gonna go over here and I'm gonna borrow all of this code. Copy, paste. Okay, here we are. Here's a nice set of code, and we have to put our code there. Okay, so and so and so it's going to be a class called product. Let me bring up my trusty notes. I had those around here someplace. Oh yeah, okay. So here's what we do. Well, we start with one of these inits, and I'm sorry, can I get rid of this somehow? Yeah. I'm gonna want to have some cheat code over here, which is exactly why I included all this stuff, because so we're going to be doing class constructors. Okay, here we go. Where's a good example of one? Do we have any with some sets and gets? Does this have sets and gets? It doesn't. So anyway, so it's class constructors. So it's going to look like this. And so over here, I got to put, I'm going to type my code here. I'm just going to go this way. Init def dash init. Look at that. I tab. Ooh. No. Not gonna be fancy. No fancy. Yeah. Okay, self colon, but it's not going to be just self colon. It's going to have comma. This is the price. Oh, look. Oh, we got this here. Get code. Okay, we have to create a get code, and we have to create a get count. And how about a price? Do we have to get price? We might have to. Okay, so anyway, so I got to put code. So what gets passed in? Geez, I got to pay attention. Name, price, number. Okay, so name is the code. Yeah, see, name is the code. Price is the get price, and count is so I'm going to name them code, price, count. Code. So the first one that comes in is going to be called code, and the next one that comes in is going to be called price, and the third one that comes in is going to be called count. Okay, how's that? And then after that, I need to put. See, I would put pass if I just wanted to test it now, because there's got to be at least one thing in there, and pass is like a no operation. Self.code, so it's going to be a variable self.code, and that's going to be equal to the code value coming in. See, I conveniently name this the same as this, just so I don't get confused. But it is actually kind of confusing, because if this were to be a different name than this, then of course this name would be the same as this name. But anyway, so I'm going to do a self.price equals price, and we're going to do a self count equals count. Okay, so that's going to take care of the init, and so that's going to create an instance based on these coming in. Okay, so what do we have to define next? Well, we have to define a set, because we're set. We do. Why do we need a set? Are we setting? Oh yeah, we're gonna add a cell, set code, set price. Okay, we gotta create all these things. I see. That's why they're all here. So I might 122. Let's see if I can get through this. Okay, so first I'm going to define a set code to set underscore code. This is a method where that I use to set this value. Seems kind of like a lot of code to do something so easy, but okay. So this is my code. Why is it? Why doesn't it? Is it because I have this? No. Anyway, colon and all it is self code equals code. Kind of dumb, right? And then we're going to have a code. Then we're going to have a def get code that this will return. Just have to do this. And this will return. So I do a return self.code. That's all. And then I'm going to do the same for price. That'll be for price. And then for count. Okay, so I'm going to do this. Lazy. And it's nice in Visual Studio Code because it keeps track of whether you're putting spaces here or tabs, whereas other times it's not. So this has got to be, I have to change, I wonder if this is going to work. So I want to change, find code and change it to price. Let's see if this works. Now where's find? Replace all, replace, okay. Price, 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 price. Next, I want it to be count. Change, 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 change. Okay, great. So I made all the methods to be able to set the codes and get the codes and set the price and get the price and set the count and get the count. And the last thing I have to do is this add inventory, def adding inventory. So add underscore inventory. And this is going to be a self and then plus an amount. And all this is going to add self.count. It's going to add amount to that. That's all. Okay, and I also need a def cell inventory, and that is also an amount. And in that case, we are subtracting from inventory. Okay, so this might be all that it is. Okay, so this is kind of stupid. It doesn't really ask the user to enter anything. So this is kind of a weird. So you know, since there's no input, then to test it would just be to run this and check all the numbers, and who cares about the any branches? There aren't any branches. It just goes down the line. There's no branches, and there's no inputs. There's no checks. There's no loops. All right, so let's just run it. Let's see. Terminal. Here's my terminal. Let me just do this. And can I? All right, so I'll save it. And let me run it this way. Let me press this. Run and debug. Python. So it just runs, and this is the output. And what does this look like here? Well, it's got no input, and let's see what this output looks like. Get rid of this. What does this look like? I mean, Apple 4.3, Apple 4.8, Golden Delicious 0.554. I don't know. Well, okay. So once this is done, what you do is you take it's basically, this is the code that you got to type in right here. This is the code. So you take this code and you paste it in right here. You paste it in right there and submit it. So anyway, that's what you do. It's 128. That's all I have for today. And next, that's me. So I will, I'll see you next week, and we'll get back into this. A busy week this week, but next week should be back to normal. And are there any questions?
No, sir.
All right.
Thank you.
Thank you. Hearing none. Have a good day. Thanks for watching.
Yeah.